In question 18, we're asked to examine a set of data from an experiment and the results are recorded as x and y. Now it's very important here that on the graph paper we had to plot values of y against x squared, and that's the key thing here. So what I've done is I've created a little sub row called x squared, and we can see that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16 and 5 squared is 25. And then we plot those values against the y values, and as you can see on the graph, when they're plotted they make actually almost a straight line. I've then drawn through those points to show that fact, and then in part B it said it is known that y is approximately equal to y equals ax squared plus b. Use your graph to estimate the values of a and b. Well, because it's a straight line, we could say, well, we know that the formula for a straight line is y equals mx plus c, where m is the gradient and c is where it cuts the y-axis. Well, we can use those facts here because obviously we've got a coefficient of x squared, which will be our gradient, and our plus b will be equivalent to our plus c. So using the rule y equals mx plus c, the c value is normally where it cuts the y-axis. So in this case, our b value is going to be where it cuts the y-axis for this graph, which just happens to be at 70. Now our gradient from y equals mx plus c is going to be our a value. Now the obvious thing here to do is take the start point we've estimated there as 70 when x squared is 0, and then go along 10 units. And if we read off at 10 units, we can see we've got roughly 155. So a is going to be our difference in our y's, which is 155 take away 70, over the difference in our x squared, or difference in our x's, okay, which makes a nice right-angled triangle. Well, 155 take away 70 is 85, and 85 divided by 10 is 8.5. So therefore, this equation of this line is y is equal to 8.5 x squared plus 70.